Throughout this series, we've gone from LTE to new radio, from specs to signals. In this final episode, we'll connect those RF features to what really matters: real networks, real deployments, and real-world trade-offs. Compared to LTE, 5G RF systems are significantly more complex. Wider bandwidths, multiple numerologies, massive MIMO, and dynamic spectrum usage. But this complexity enables unprecedented flexibility, allowing networks to adapt to traffic, spectrum availability, and deployment constraints. In 5G, RF performance is no longer defined by a single parameter. Coverage, throughput, and reliability depends on the interaction between power control, beamforming, scheduling, timing, and receiver performance. Massive MIMO and beamforming redefine how energy is radiated and measured. This shifts RF testing from conducted measurements to over-the-air methods, especially in FR2, impacting design, validation, and certification. Ultra-reliable and low-latency performance doesn't come from raw power alone. Precise timing alignment, fast HARQ feedback, and adaptive scheduling are equally critical, especially for TDD and URLLC use cases. Energy efficiency is no longer an afterthought. From envelope tracking in UEs to beam-based power shaping and cell sleep modes, RF design directly impacts sustainability and operational cost. PGPP RF conformance testing ensures that all devices, UEs, and base stations can coexist reliably in shared spectrum. It's not about passing tests, it's about protecting real networks. For RF engineers, the biggest takeaway is this: 5G success depends on understanding interactions, not just specifications. Design, test, and optimize with the system in mind. This series covered the RF foundations that power modern 5G networks, from spectrum to testing, from devices to massive MIMO systems. Thank you for joining me on this journey through 5G RF engineering. If you found this useful, subscribe for more RF insights, and stay curious, because the path to 6G has already begun.